Okay, in this section we're going to look at ellipses. They look very similar in their form to a circle, but instead of what we had before with a circle, we had actually the more general form was this for a circle equals r squared. What we've got here instead of an r squared on the right is a 1. So that's kind of like if I took this equation and divided everything by r squared, that would give me over here a 1. So I'd have that. So that's sort of the format, I guess, for a circle, and you can see on the bottom here that the r's are the same, and that's because in a circle, wherever you are from the centre, you're the same distance, the same radius away. Now in an ellipse, which is an oval, you're actually going to have different distances from the centre because, for example, you've got a shape like this or a shape like this. And that's why these numbers on the bottom are going to be different. One of them is going to tell us how wide we are in the x direction, which is the one underneath the x minus h squared part. And one of them is going to tell us how wide we are in the y direction, and that's this number b here. So it's sort of like a radius, I suppose, in the x and y directions. It's mathematically called a semi-axis. And we talk about two axes in an ellipse. We talk about for example, in this one, we have what's called a major axis, and the short little sort of fat axis is what we call the minor axis. So we have two types of axes that we look at. Works the same way with translation, and it pretty much is just about finding the center of your ellipse and then plotting out where the ends are for your semi-axes in both directions, and then joining it up. So very much like the circle. And we also use completing the square in the same way that we did for circles as well. So if we have a look at these ones, we've got the first one, A, we've got x squared on 9. I'm going to write this out as 3 squared, so like it's a radius squared, and y squared on 4, which I'll write as 2 squared. When I sketch this now, I know from my equation that my center is going to be, there's no translation, you see there's no h and no k, there's no shifting terms here, so my center will actually be at the origin, and we're going to have in this direction our radius, I suppose in the x direction will be 3, our radius in this direction will be 2 because that's what's underneath the y. So I'm just going to sketch this quite roughly. 3 will be a little bit bigger, x and y. So you should really measure this out so it's quite a bit more accurate, and I'll do it in blue. I'll do it in a different colour. We'll do it in light blue. And then it's just a matter, oops, I'll do that again, of putting your circles in, your dots I should say, and then joining them up. Now I find, especially when I'm on this tablet, it's a bit hard to do it in one go. So you might find it easier to just join up a portion and then join up each other, the next portion, so rather than trying to do it all at once. So that's your first ellipse. It's a long ellipse, so it's got the major axis in the x direction. Now we can see the one underneath, here, which is B, it actually is around the other way. So you've got the 2 squared underneath the x squared and the 3 squared underneath the y squared. So with this one, you're just going to have the same ellipse. The center is still in the same place, which is at 0, 0, because you've got no translation with the x and y. But we can see here that in the y direction, we're going to be going 3 as a sort of radius, and in the x direction, our semi-axis is going to be 2. So it's basically the same ellipse that's been spun around 90 degrees. And again, same deal, just put down your end points. In terms of labeling, if you've done your tick marks, you know, it's very easy. So you might want to label, maybe label the extreme points. So something like this. And it's usually an idea as well to label the center of your ellipse. So I should really do that here as well. Okay, now we've got two others. So I'm just going to copy those to the next page so we can do those as well. So these two are a little bit more difficult. We've got a shift or translation, and we've also got one where we're going to need to complete the square. Okay, so the first one here, we can see the center. Oops, I'll write that again. I was a bit confused. The center for this one is going to be at 2, 3 because you're opposite signs. And we know that in this direction, so the y direction, it's 4 squared underneath here, so it's going to be like a radius of 4. And in this direction it's 3 squared, so it's going to be sort of a radius of 3. So that's, I suppose, I'm just going to write here. It's not called a radius, but it just helps to understand what it basically is. So we'll put that axes in. Going to need to be a bit further over to that side. And we'll put in, first of all, our centre, which is at 2, 3. Might not have enough room. There we go. 2, 3, which is there. So I might label that. And we need to go, because of this 16, we need to go the square root of that in each direction. So 4, 1, 2, 3, 4 to there, and 1, 2, 3, 4 in that direction. So this is going to be 2, negative 1, taking 4 off the y and adding 4 to the y. So 2, 7, x, just doing a bit of labelling. And then in terms of our radius this way, we're going to go 3 to the left, so 1, 2, 3. So take away 3, which gets you to negative 1, 3, and add 3, so 3, 4, 5, so it'll be there. So it'll be 5, 3. So there are extreme points on our ellipse, and then I'm just going to sketch those in, like that. Okay. The last one is this one here. Now this doesn't look like the standard form we're used to. With this one we're going to need to complete the square. So I'm going to look at the x terms and then the y terms. Now you can see here there's actually no y on its own term. So we're then going to look at this as like being the rest, you know, the added on bit. So let's look at completing the square. So we're going to do completing the square on, I might actually just put another column here. Do our graph on the other side. So completing the square on 3x squared plus 24x plus y squared plus 36 equals 0. Now first thing you want to do is, see how you've got a constant out the front of the x squared, factor that out. So you're going to complete the square on what's left after you've divided both these terms by 3. So take the 3 out. So you've got x squared in the bracket because that's the 3x squared. 3 goes into 24 8 times. So it looks like that. Now the y squared, because there's no y term to go with this y squared, you can't do complete the square on it. So this actually is already a square. It's completed, so it's not going to be shifted at all. It's just going to be y squared. And 36 just stays like that. So now we can do completing the square on this part. So we've got x squared plus 8x, coefficient of x is 8, so halve it, that's 4. We're going to square it, 16, we're going to add it and subtract it, and then we're going to add on the rest here, which I'll just do in that colour, in blue. So we've got this part here, which is going to be a perfect square. So we've got 3 outside of x squared, and this is going to be, oh, I should say x plus 4, and that's going to be all squared. Now what you might like to do here is, instead of using these round brackets here, you might like to use square brackets. It looks sort of neater. So that's these 3 terms taken care of. That's the perfect square, minus 16. Put a square bracket on the end here and write the rest of it down. And then if we're wanting to now work with everything all together, what we need to do is expand this 3 across. So the 3 will be now in front of this bracket, like that. But the 3 is also going to go with the 16. 3 times 16 is 48. So I'll just put in green here. You're basically doing this. Okay. So now that you've done that, you've got rid of your brackets. Oops, I'll just get my blue pen back. And we can write everything else down. And now finish it off. So we've got 3 outside of x plus 4 all squared. The constants here, we've got the minus 48 and the plus 36. And if we take 36 away from 48, that's going to be 12. So it's going to be minus 12. I'll just write the y squared part here. Now what I'm going to do is, to get this 3 out from in front of the x plus 4, divide everything by 3. So we've got x plus 4 all squared, with the 3 out the front. We're going to divide that by 3. I'm going to divide the y squared by 3, and let's take this 12 over to this side, and I'm going to divide that by 3. So you can see I've divided every term here by 3. Now the cool thing is that the 3's cancel on this term, and the 3's are going to simplify here, so we end up with an equation that looks like this. X plus 4 all squared plus y squared on 3 equals 12 over 3, which is 4. And the last thing I'm going to do to make this look like an ellipse is to get a 1 on the right hand side. So I'm now going to divide both sides by 4. What you could do at this point is actually divide everything by 12 if you wanted to as well. That gets you to the same place. So divide everything here by 4. That's divided by 4. Dividing by 4 here makes that a 12, and it makes that a 1. So this is now in the form that we can use. So we now know that we've got our centre, which is going to be at, remember it's always the opposite sign, so it's -4, no shift on the y, so it's actually not up or down. And we're going to have, in terms of our radius measures, in this direction, so in the y direction, it will be the square root of 12. In this direction, it will be the square root of 4, which is 2. So that's what our ellipse is going to look like. Now you might like to estimate for what the square root of 12 is, just so you can sort of estimate where to put that, or you could use the CAS. So, oops, square root of 12. Now if you've got this in exact form, you won't actually get an estimation, so do Control and Enter, so you're using the little approximates. So 3.46 is around about where that needs to be. So now we can sketch this up. So just our axes, oops, and first of all put on our centre. I'll just shift this up. So at -4 and 0. There we go. And we've got our, it's about 3.4, 3.5-ish, something like that, roughly. And 2. So we're going to go 2 in each direction in the x direction. Label this as -4, 0. And we're going to go about 3.5 sort of here and here. And then we can just sketch in the rest of our ellipse like that. So we've put in our centre, and you could also label these points. If you want to label these, the best way to label this is probably in the exact form. So like that. Or even if you wanted to, I'll do it here. You could simplify this. This is 3 times 4. Square root of 4 is 2, so it's 2 root 3. So you could actually write it like that as well. And then here on these sides you'd have -2, 0 and -6, 0. So that's your ellipse, using complete the square to get it from this standard form into the centre sort of semi-axis form, which is a bit easier to sketch. Oh, better make sure as well I didn't put a negative there, -2 root 3. So now that we've done that, what we want to do is just go through how to do this in your CAS. I might put maybe this one in the CAS as sort of interesting looking. So what we're going to do is just go into the CAS. Now I was putting circles in before, so to change it to ellipses, go to Menu, Graph Entry, and Equation, and we want an ellipse. Now you've only got the centre form here, so you can't put the standard form in. So if we look at our example here, we have a +4 over 4, which is 2 squared. So we're going to do a +4. To do a +4, we have to put -4 in here, so that's a plus. And this is going to be 4, so it has to be 2 squared. And then the other part is a y squared over 12. And you can see it's all equal to 1. Now y squared means that there's nothing here, so a 0. Now for the 12, we don't put 12 in here because it's not 12 squared. It's actually the square root of 12 all squared. That will give you 12. So that's going to be our ellipse, and then push enter. And there's our ellipse there. Now you can see it looks like the one that we sketched, so it's a bit over sort of 3.5. And to look at the information about this, just click on it and then click Menu, Menu 6, so Analyze Graph, and 9, which is Analyze Conics. And we can look at the vertices on this graph. So you can see here that it actually labels your vertices as -4 and -2 root 3. and positive 2 root 3. And if we wanted to look at as well, we can look at, I suppose the centre would be the other thing we'd want. So if you hover over the centre now, you can see that centre is at negative 4, 0.